Hey there! Welcome to this lesson on IP addresses, DNS, subnets, and routing. If you've ever wondered how the internet works behind the scenes or how AWS keeps everything connected, you're in the right place. Today, we're going to break down some key concepts: IP addresses, DNS, subnets, and routing. Don't worry, we'll keep it simple, interactive, and fun. Let's start with IP addresses. An IP address is a unique identifier assigned to every device on a network. Think of it like a phone number. It's how devices find and communicate with each other. In AWS, IP addresses are crucial because every resource, like an EC2 instance, an RDS database, or a load balancer, needs one to function. AWS uses two main types of IP addresses: public and private IP addresses. Let's begin with the former. Public IP addresses. These are used for resources that need to communicate with the internet. For example, if you're hosting a website on an EC2 instance, it will need a public IP address so users can access it from their browsers. Private IP addresses. These are used for internal communication within your AWS network. For instance, if you have a database that only your application servers need to access, it will use a private IP address. One more thing. AWS also supports elastic IP addresses. But before we talk about elastic IP addresses, let's take a moment to understand why they're needed. Imagine you're running a critical web application on an EC2 instance. This instance is assigned a public IP address automatically when it's launched. Now let's say you need to stop and restart the instance, maybe for maintenance or updates. When the instance restarts, it gets assigned a new public IP address. This might not seem like a big deal, but think about it. If your users or other systems are connecting to your application through its IP address, a change in the IP address means the connection breaks. Suddenly, your application becomes unreachable until you manually update the new IP address wherever it's being used. This is where elastic IP addresses come to the rescue. Unlike regular public IP addresses, elastic IP addresses are static, meaning they don't change, even if you stop and restart your instance. This ensures that your application remains accessible at the same IP address no matter what happens behind the scenes. It's a simple but powerful way to maintain reliability and reduce the risk of downtime. Now let's move on to something that makes IP addresses a lot easier to work with: DNS. DNS, or the domain name system, is like the phone book of the internet. Instead of typing a long string of numbers like 142.250.190.14, you can type google.com into your browser. DNS translates that friendly name into the IP address your computer needs to connect to. In AWS, DNS is managed by a service called Route 53. Route 53 is a scalable and highly available DNS service that lets you register domain names, route traffic to your resources, and even check the health of your applications. All right, let's move on to subnets, which help you organize your resources within your AWS network. Subnets, or subnetworks, are like dividing a large neighborhood into smaller streets. In AWS, a subnet is a range of IP addresses within your virtual private cloud, VPC. A VPC is your own private section of the AWS cloud where you can launch resources like EC2 instances and databases. Subnets help you organize and secure your resources. For example, you might have a public subnet for resources that need to be accessible from the internet, like web servers. A private subnet for resources that should only be accessed internally, like databases. Subnets are also tied to availability zones, AZs, which are isolated data centers within an AWS region. By spreading your subnets across multiple AZs, you can make your applications more resilient to failures. For example, if you have web servers in two different AZs and one AZ goes down, your application can still run from the other AZ. This is the power of subnets and AZs working together. Now, let's talk about how traffic moves between these subnets and other networks using routing. Routing is all about directing traffic between your resources, the internet, and other networks. In AWS, routing is managed using route tables. Every subnet has a route table that contains a set of rules called routes, which determine where traffic is directed. For example, if you want your web servers in a public subnet to access the internet, you'd add a route to an internet gateway. If you want your application servers in a private subnet to access a database in another private subnet, you'd add a route to the target subnet. Let's take a scenario. You have a web server in a public subnet and a database in a private subnet. To allow the web server to access the database, you'd set up a route in the web server's route table to point to the private subnet. Routing is a powerful tool that gives you fine-grained control over how traffic flows in your network. And with AWS, it's all managed through simple, configurable route tables. I hope you found the lesson interesting. See you in the next video.